Great. Hi, everyone. This is an exciting topic. And the great news is that in my demo, I'm going to try to break my entire microservice architecture. So you really want to stay tuned for that, because sometimes, I really do manage to break it. So this is Supercharge Your Spring Boot apps, and I'm going to show you how to create microservices with Azure Spring Cloud. You can follow me at Rory Preddy. I do 50% memes and programmer humor, and 50% Azure and Java updates. So who am I? I work in the developer relations team as Microsoft as a senior cloud advocate for Java, and shameless plug at the Java Twitter advocates and Java at Microsoft account. Follow us at Java at Microsoft. It's a great way to see the ongoing investment with Java at Microsoft. So let's start. Let's set the stage. Spring's flexible libraries are trusted by developers all over the world. From the latest Snicker report, a significant number, 50%, indicated Spring Boot as their framework of choice. Most of you already have dozens, if not hundreds, of Spring Boot applications in production already. However, business is blooming, especially in this COVID climate. Everyone is going digital. Technology is evolving. Distributed teams are also changing. Companies are looking to become more agile so they can innovate and respond to change faster. So how do we supercharge this opportunity? In large distributed projects, we firstly need to let each team work independently, build, verify, deploy, and monitor their services. Applications need to scale quickly and to potentially millions of users across the globe. We need independent services that can be scaled based on their respective demands. And we also need to work more efficiently through an end-to-end development process and make it wondrous for developers coding, debugging, development, monitoring, and management with integrated tools and DevOps. Then we'll have a chance to achieve reliability and faster time to market and supercharge our applications. So achieve these goals for today's sessions. I'm going to act both as a developer and also later as a member of the DevOps team. As a developer, I'll explain how to build my services independently and run them globally. As DevOps, I'll show you how to scale these services and manage the app's lifecycle efficiently. Finally, I'm going to show you how to deliver value faster. So let's get started. Microservices. So microservices are a software architecture style in which applications are composed of small independent modules that communicate with each other using well-defined API contracts. Each service is actually a highly decoupled building block that is small enough to implement a single functionality. Typical microservice project consists of a collection of many of these services. Besides the services themselves, let's discuss also some of the other components that appear in a typical microservice project. My services need management and orchestration components. These components are responsible for placing services on nodes, identifying failures, and rebalancing services across nodes. As you can see from this diagram, we also have some microservices which expose external APIs to clients. In a real-world systems, this number can grow very quickly, as well as the entire system's complexity. Usually a much better approach is to use an API gateway. So that's how you build your services independently. Let's now discuss building services and running them globally and running them in the cloud. To achieve this, I'm going to use Spring Cloud as my base framework. So Spring Cloud provides 4 key modules necessary for our microservices. Spring Cloud Gateway provides a simple yet effective way to route to our APIs. Spring Cloud Service Registry allows automatic detection of network locations for service instances. With a config server, you have a central place to manage external properties for your applications. And finally, Spring Cloud Sleuth can ease debugging by providing distributed tracing. With orchestration, typically this component is an off-the-shelf management such as Kubernetes. You see, I pronounce it correctly. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It has many of the features I'm looking for orchestrating my microservices. As you can see from this diagram, this is a typical flow of what and Kubernetes rollouts actually work. But it seems I have to learn a bunch of things like pod, scheduler, YAML, don't tell Bruno about YAML, and how to operate them. What I'm really looking forward to is an approach to easily operate and manage my infrastructure. Spring Cloud components and Spring Boot applications on hundreds of instances. So my main goal is to set up and host a Kubernetes cluster, build and host Spring Cloud registry, config server, and distributed tracing, and to containerize my Spring Boot applications, deploy them to a Kubernetes cluster, and wire up the applications with the Spring Cloud components. Then perform stop, scaling, and other operations to manage the application's lifecycle. Let's look at, I mustn't dance so much on my with my headset, it actually comes off. Let's look at how to Azure Spring Cloud maybe the platform that we can run Spring Cloud in the Azure ecosystem. So Azure Spring Cloud removes the burden and related challenges of setting up and managing Spring Cloud components and Kubernetes. It's a managed service for Spring Boot applications. So let me focus on building the application to run my business without the hassle of managing infrastructure. We have dozens of microservices. I can automate the resource management and application deployment using my favorite DevOps tools. We have a big team. I can monitor the health of the applications and isolate the failures to some microservices using Azure Monitor and achieve authentication using Azure Active Directory. Spring Cloud is integrated into the Azure Active ecosystem, and as a result, it's very enterprise focused. Great. So we've decoupled our applications to microservices and showed you also how we can run on Kubernetes. Let's see how we can scale them based on their respective demands without impacting the overall performance. And to do this, I've got a very, very nice kind of holiday-based slides section for you. As part of my reactive monitoring, I also need built-in features that help my microservices perform their best when demand changes. Take, for example, Black Friday. My customers begin researching in October, but the season truly kicks off in November, with spikes with my service occurring in the last 4 months of the year. I'm already getting emails on Black Friday specials. I expect to see a significant negative impact to install visits with the COVID climate, but double-digit results to online sales. I'm going to need a business and technical strategy. My business strategy needs a way to ensure that all my customers can minimize their experience of downtime, and I need to minimize my operation costs and optimize my resource usage. Seasoned CIOs have a rule of thumb that you calculate as best as you can the maximum load, and from that the number of instances and servers that add up, and well, you need to add a fudge factor, also 20%. Then you hope that you don't get called on a Friday night when the load unexpectedly spikes. In the cloud, the strategy is inverted. Rather than allocated for the maximum load, ask what the minimum footprint is in terms of instances in the cloud. In the cloud, you can always scale up. The important thing from an economic point of view is to be able to scale down, to releasing the instances and thus reducing the charges. You don't have to pay for what you don't need. Now that I have a business strategy, let's look at some technical approaches. There are 4 core scenarios I want to cater for. I need to scale specific apps. In this approach, we scale the number of individual app instances. If I want to scale differently on weekends, then in that approach, we scale down to 1 instance on weekends. If I want to scale differently during holidays, then during the holiday season, we override the defaults and have more capacity at my disposal. And finally, we scale based on custom metrics. In this approach, we scale an app based on CPU and memory. It looks like I need to configure my application to automatically scale. This is where additional instances this is when you schedule additional instances, and you can expect a heavy load and release them when no longer needed. Pay as you go. Have you ever thought that someone could actually have a pay-as-you-go mindset for your production instances? So in Autoscale, your apps will be scaled to exactly how many instances you need for the load, but never go beyond the limits that you set. It can be configured with a range of metrics, ensuring your scaling is linked to your service, app, or even VM's performance. You can even schedule based on instance count and calendar, ensuring your apps to be scaled based on your predefined schedule and limits. The Autoscale service also provides metrics and logs to understand what scale actions have occurred and the evaluation of the conditions that led to those actions. How much of your performance was based on actual physical need for your servers? You can find answers to questions such as, why did my service scale or not scale? Why did an autoscale action fail? Why is an autoscale action taking time to scale? Whatever the resource is scaled, an event is logged in an activity log, the Azure activity log. You can view the scale history of your resource and get notifications sent directly to you. If you want to integrate to DevOps, we also provide this ability with webhooks on every evaluation and autoscale action. So enough slides here. I've done 12 minutes of slides. Let's do some demos and let's break some stuff. So what have I actually done on my demo? So if I go to my demo here, and we'll come back to our demo a little bit later. So we've got a Spring application here, and it's the Spring Pet Clinic. And I can click through here, and I've got owners and pets that I am keeping a pet clinic. Now I've got code spaces here. We're going to try to break something on our demo. Now what I've done here, if I click through, I can go copy, and I can go paste. You can see there, I'm actually pulling a very large curl of all my resources for all my pets. I'm literally calling the entire database. So, Rory, what are you going to do? I'm going to call this 2,000 times. So I've got this curl, and I've got no cache settings there. And I've got, towards the end of it, I've got 2 sessions there, and I'm going to do this 1,000 times times 2. And I've got it on my script, and I'm running in code spaces. And it's just pummeling my system. And I can actually, and we'll come back to the demo now when we finished on our slides. And we can see here my server response time, and everything kind of is nice and neat. We're going to come back to it here, and I've got 7 servers. And what I'm expecting to see is that my observed capacity count will spike up. My server response time won't actually spike up that much. No failed requests. My CPU time will remain stable, and also my available memory. And that's the end of our session. We're going to come back to our demo and see, hopefully I broke something. Actually, no, I'm kidding. Hopefully I didn't actually break something. And then we'll come back to our demo. Great. So now that our demo is running in the background and I'm trying to break it, and we'll see exactly what happens. And then, I'm not promising anything, but the autoscale should actually pick up. And what I'm doing on the demo is I'm actually checking that the total session counts is less than a few hundred. And if it's more than a few hundreds, I'm going to scale up with a few servers. So let's look at also how to be proactive through the app life cycles. Now, we want to have a development experience and a glorious development experience. So we want to be able to accelerate development. And we do this also through our deploying of our applications. So after deploying your applications, my applications are actually automatically wired up to Spring Cloud Config Server and the service registry. So I don't have to do a lot of nitty-gritty kind of microservice engagement. It just picks it up with the Eureka service. So my applications can interact with any Azure or external service. Besides jar artifacts, so jars, Java archives, I can directly deploy service code through the built-in VMware Tanzu build service, which generates container images from source code. VMware Tanzu build service, Rory? No, you have to show me this. So the Tanzu build service relies on KPAC, which is an open source Kubernetes native build engine, which automates the creation and updating of containers images using cloud native buildbacks. Literally, it creates a custom image for me on Docker with a Docker image, and it introspects using AI to create my Docker image. I know, how cool is that? And the build packs separate out the base image, the runtime, and the applications into different layers, and they're quick to update only the layers that change. While KPAC and Cloud Native build packs are not exposed to the users, I can rest assured that the Azure Spring Cloud is running them for me. So I'm going to show you a little bit of the magic here. So watch the screen here. As you can see, you only need one command, and you get your source code containerized and up. And what you'll see there, it starts to analyze your Spring Boot application and add the layers there. This is done a little bit quicker. Add the layers in there, and then it builds your application, chucks it into the container registry, and it's done. And I remember when I did this first, I couldn't actually believe that they had created AI technology to analyze my application and run it for me. Let's look at also how Azure Spring Cloud can assist with monitoring. Without the box support for Azure Monitor, Azure Spring Cloud can easily visualize how my Spring Boot applications and my Spring applications are performing and isolate potential problems. So I can set rules for some of the important conditions and address issues before end users notice them. So this is the application, the pet clinic application. And you can see here, I've got my instances, and when they scale up, I can see how many of those instances, how long each call was done, if there are any errors, in this case, the get health, because I'm not actually running a health check on them, and also the round trip for the service, for the threshold monitoring. And this is wondrous for developers, because microservices are very difficult to be able to debug in production. We would never debug in production. So before we jump back to our demo, let's also look at how to deliver the value faster. And you do this really with Spring on Azure starters. And they allow you to make your code portable. And these are open source libraries backed by both VM and Microsoft that further simplify connection and consumption of Azure managed backing services. They give developers a Spring idiomatic way to connect and consume Azure services with only a few lines of configuration and minimal lines of code. These are like bombs, if you're familiar with bombs. So as you adopt them, you follow a set mindset and an idiom, and you can kind of just connect to monitoring, storage, streaming, Cosmos, MySQL, distributed caching, security services without having to worry about the underlying kind of wiring of that. And we have so many, it's part of a rich ecosystem, the Spring starters. You can also find many additional Spring starters in the Azure ecosystem. And you can find a lot of these projects at https://spring.io. So with this summary here, I think we found the platform to supercharge my Spring Boot apps and deliver features to the market faster. And it's going to let me focus on application iteration and debugging, and let the platform manage all the other responsibilities. So let's go back to our demo, and then we can show you some nice slides around the roadmap. Okay, let's go back to our little demo. And we can see here, so code spaces are overwhelmed often, but let's see if we can just do a refresh here. We should actually see if the demo gods are playing nicely. There we go. We've got an autoscale here. We've got 0 errors here. We've got the runtime with a little bit of a spike here, but we're scaling up to 3 instances, memory stable, average processor and CPU time. And we can actually click through on our application and go see exactly what's going on. We can also go see that we had 7 servers, we have 9 servers. So we're scaling up, and to handle that load is ready here. And we can go to tracing for our autoscaling, and we can go, I don't want to see the last hour, I want to see the last 3 minutes, apply, and I can go debug those instances there. And let's go customer service, which is the one that we do that. We can go investigate performance. And I can go see there that my performance is stable. I've got my request counts, and also the request counts, and I can drag, check how cool that is. I can just drag it over there and it will zoom in there. My request counts are really increasing, but my performance is getting better. How? Wow. That means I can actually handle the Black Friday, boom that is coming out. I've got my Spring Boot application deployed there. I got my pet application, my pet clinic application. I've got my service scaling up. And also, don't forget, I've also got on my application, I'm going to scale down. I'm going to show you how to do that quickly before we go to the final bit of our slides. So let's go all resources. I'll show you my Spring Boot application here. Got my Autoscale application, and I've got my apps. Now I've created the classic Spring Boot application, API gateway, customer service, vet service, and visit service. And on there, I've got the scale out, which is in preview. But also you'll see here when I go into scale out, I've got my 2 servers. So I'm scaling out as we talk. And I've got scale out when the Tomcat global resources is greater than, and you can see here 10. So basically any load, but then scale in, and it's going to scale in now when, and you can see here, when then less than equal 10, because I want to have that pay as you go experience. So we really can kind of lessen the cost there, and I can get all that logs when I want to see it. So I can go there. I can go to customer service. I can go run history, and you'll see here the logs will come here, scale up complete, and then it's busy doing a scale down. And the scale down will take a few seconds to do that. But if I show you here the scale down, and I've done it before, let's go 12 hours. Yeah, you can see there the scale down just minimizes my costs and goes back to those original servers. So let's go back to our PowerPoint slides. We're nearly finished. Thank you for holding on. So I've got my, so in this summary, we've got our platform to really supercharge the application. So it's available now with 99% SLA and in production. You can use it now. It's enterprise ready. We've got a wondrous roadmap coming around. We've got some security features that we're going to put in there. We've got a VNet that is going to be generally available soon, with Autoscaling also general. We're rolling out to all the different cloud systems there. If you want to learn more, you can use your Azure account, get started with Spring Cloud today, and leverage the expertly maintained Spring Docs references. Then integrate with Azure Spring Cloud starters into your project and introduce Spring idiomatic Azure libraries. And finally, spend some time with our workshops and get detailed experiences with Azure Spring Cloud. We also have some sweepstakes for our Azure survey that you can do. So you can go acad.ms/2020-spring-survey, and you can stand the chance to win $150 gift certificate. And I know that Bruno wants to chat to me now, so I look forward to actually some really great questions from him. Thank you so much for everyone for listening to me. And we didn't manage to break our Azure Spring Cloud. I tried, I really did. I have broken it before in other demos. But let's go back to Bruno and see if he's got some nice questions for me. Bruno, over to you.
Rory, I think you didn't break Azure Spring Cloud because we are,
2,000 transactions, pulling an entire database and under each one of those. That is some.
I don't know.
I really did try to break it.
We need more. We need more transactions, man. Can you go up to 20 million transactions? Maybe.
I have, but then the scale up and scale down would take too long. So I've timed it perfectly with the 2,000 transactions because I wanted to show you that it had started the scale down though. So in one of the talks, I did 20,000 transactions.
20,000?
Yeah, but the nice thing about the 20,000 transactions is that you can actually literally see that a lot of the times as the new servers come up, because it's got a gateway, it starts to really take the load to 30%, 30%, 30% on the servers. And you can scale up to 500 instances with those servers. 500 microservices.
So you have 500 JVMs up and running.
Yes. And you get up to I think.
So one customer, one account, 500 JVMs. And we do have customers already, right? On Azure Spring Cloud. I heard.
They want more, hey. When you see
want more.
how powerful this application is, you want more. Because remember, you can actually run more than one Spring Cloud instance, and you can get them to speak to each other. So you have one Spring Cloud instance, then you can have another with another 500 and more and more and more and more.
So so I'm a Java developer, you know, right? But I'm trying to learn .NET. Can I run .NET on Azure Spring Cloud?
Yes, you can. So in preview, we've got Steel Toe. So Steel Toe, whatever you saw that I just did now, you can do the exact same for .NET applications.
Okay.
And we're experiencing such a crazy concept that you can run .NET and Spring applications on the same server.
So can I run my, so when I run my .NET application on Azure Spring Cloud, does .NET runs on the JVM?
So remember,
okay, so let's jump on to the last speaker. Because so for folks watching, yes, you can run Stuto. It's a project that was jointly made between Microsoft and Pivotal, now VMware. We are working on this support. So if you're a .NET person watching JDConf, I don't know why, but welcome, thanks.
We love you. We love you still.
We love you.